What specific problem does MetaClip 2 aim to solve in relation to existing models like CLIP and its variants, particularly concerning multilingual data?
MetaClip 2 aims to address the significant challenges associated with training CLIP models on multilingual data, specifically, the curse of multilinguality that results in poorer performance for non-English data compared to English-only models. Existing models, such as MSIGLIP and SIG-LIP2, either rely on proprietary data sources or machine translation, leading to biases and suboptimal performance. MetaClip 2 introduces a novel approach by developing a comprehensive data curation method that handles native, worldwide image-text pairs without outsourcing or distillation, thus ensuring a balanced training distribution across multiple languages. Additionally, it enhances model training by scaling the number of seen image-text pairs proportionally to the growth of non-English data, which helps to eliminate performance trade-offs between English and non-English tasks. Ultimately, MetaClip 2 enables mutual benefits from both English and non-English data, achieving full multilingual support and improved cultural diversity in model performance.
How does the proposed MetaClip 2 method work? Please illustrate it step by step, focusing on the key components like data curation, metadata construction, and training framework.
The proposed MetaClip 2 method operates through a systematic approach that includes three key components: metadata construction, data curation, and a training framework. 1. Metadata construction. MetaClip 2 constructs independent metadata for each language, utilizing resources such as Multilingual WordNet and Wikipedia to cover 31 languages. This ensures that the model can accurately match concepts across different languages, addressing the limitations of previous English-centric models. 2. Data curation. The curation algorithm processes raw image-text pairs by first identifying the language of the alt text and then applying language-specific metadata for substring matching. This results in a balanced dataset that maintains a proper ratio of head and tail concepts, crucial for effective training. 3. Training framework. The training framework is designed to scale the number of seen image-text pairs proportionally to the increase in non-English data, ensuring that English performance is not compromised. Additionally, it incorporates a multilingual text tokenizer and studies the minimal viable model capacity, which is essential for breaking the curse of multilinguality observed in previous models. Together, these components enable MetaClip 2 to effectively learn from a diverse set of image-text pairs across multiple languages, enhancing both English and non-English performance without relying on outsourced resources.
Can you provide a simple yet illustrative example demonstrating the inner workings of the curation algorithm in MetaClip 2, explaining how it handles non-English image-text pairs?
The curation algorithm in MetaClip 2 processes non-English image-text pairs through a systematic approach that begins with language identification, LID, to classify the language of each alt text. For instance, if an image has an alt text in Spanish, the algorithm matches it with Spanish-specific metadata, which includes concepts from Multilingual WordNet and Wikipedia. It then counts the occurrences of these concepts across the dataset to balance the distribution of head and tail entries. The algorithm applies a language-specific threshold to ensure that tail entries are adequately represented, maintaining a consistent ratio of head-to-tail concepts across all languages. Finally, it samples the image-text pairs based on these probabilities, ensuring that pairs associated with tail entries are always included, thus creating a diverse and balanced training dataset that supports multilingual learning.
What are the theoretical or practical advantages of MetaClip 2 over previous approaches like MSIGLIP or SIG-LIP2, especially in terms of performance and data utilization?
MetaClip 2 offers several theoretical and practical advantages over previous approaches like MSIGLIP and SIG-LIP2, particularly in performance and data utilization. Firstly, it eliminates the curse of multilinguality by jointly scaling metadata, curation, and model capacity, allowing for mutual benefits between English and non-English data, which enhances overall performance. In contrast, MSIGLIP and SIG-LIP2 suffer from performance trade-offs, with MSIGLIP being 6% worse than its English-only counterpart, and SIG-LIP2 prioritizing English at the expense of multilingual results. Secondly, MetaClip2 utilizes a comprehensive worldwide dataset without relying on proprietary or machine-translated data, ensuring that models learn from native language supervision, which improves cultural diversity and reduces biases. Finally, it sets new state-of-the-art benchmarks in multilingual tasks, outperforming MSIGLIP and SIG-LIP2 across various metrics, demonstrating its superior capability in leveraging a diverse and balanced dataset.
How is the effectiveness of MetaClip2 validated or tested? Describe the datasets, benchmarks, and metrics used to demonstrate its performance improvements.
The effectiveness of MetaClip2 is validated through a comprehensive evaluation on a variety of zero-shot transfer benchmarks, which include both English-only and multilingual tasks. Specifically, it is tested on datasets such as ImageNet, IN, SLIP26 tasks and Datacomp 37 tasks for English performance, while multilingual benchmarks include Babel ImageNet XM3600, CVQA, and Flickr 30K200. The performance improvements are measured using metrics like accuracy and recall, with MetaClip2 consistently outperforming its predecessors, such as MSIGLIP and SIG-LIP2, across these benchmarks. Notably, it sets new state-of-the-art results in several multilingual tasks, demonstrating significant gains in accuracy, such as a 3.8% improvement on Babel IN and a 7% increase on Flickr 30K200. Additionally, the ablation studies conducted on various aspects of the model, including metadata and curation strategies, further substantiate the robustness of its performance across diverse datasets.
What significant results were achieved with MetaClip2 on multilingual benchmarks, and how do these results compare to other multilingual systems developed previously?
MetaClip2 achieved significant improvements on multilingual benchmarks, setting new state-of-the-art SOTA results in several tasks. For instance, it outperformed previous systems like MSIGLIP and SIG-LIP2 by achieving a +3.8% increase on Babel IN, +1% on XM3600, and +3% on CVQA. Notably, while SIG-LIP2 prioritized English with 90% of its training data in English, it performed worse than MSIGLIP on multilingual tasks, highlighting the effectiveness of MetaClip2's balanced approach to multilingual data. Additionally, MetaClip2 demonstrated strong performance with fewer scene pairs and lower resolution compared to its predecessors, indicating its efficiency and capability in leveraging worldwide data. Overall, these results underscore MetaClip2's ability to break the curse of multilinguality and enhance performance across both English and non-English tasks.